Hi, this is Miliastra Mechanics, or Damien here. This is going to be a video on how to use the skill editor and beyond to create really custom skills for your complex creations. It is not meant to be a guide for complex creations in general, but I will briefly cover those aspects so you can follow, but knowledge of them is not required to understand the skill crafting part. Today, we're going to create a Super Saiyan Mitachurl. He will have 2 phases. To keep things simple, just 2 abilities. The first phase, he will cast Spirit Ball, and when he is brought below half health, he will go Super Saiyan, transform, be buffed, healed, and unlock the Kamehameha. This kind of thing is only possible with complex creations, which is today's focus. You can see here a before and after example of what the interaction will look and sound like once we finish giving it the VFX and audio versus the bare animation. I just wanted to say I'm going to try a new format today since this is a much more complex project than usual. I will provide the full project files with copious notes as I always do, and any other required files in the description. But instead of boring you by going over every single mouse click to set this up, I will just instead show you the completed parts and explain to you each step of them and what they do, what my logic behind each choice was. And I'm hoping by doing this is a much more intuitive way to learn this, because it explains what each part does rather than me rambling while slowly searching for a get self entity node. And hopefully this helps you with your process for solving these problems too, which is the whole point of these videos. So please let me know how you like this approach. Feedback helps a ton. And also quickly, sorry for the delay in uploads. I was extremely lucky enough to attend the Miliastra Wonderland Hoyoverse event for creators in San Francisco and fly for one of the first times ever in my life. And it took a lot of preparation, and then I got extremely sick after getting home. So I've only been able to finish this video just now. And I do have good news though that I have another one already in the pipeline. So feedback on this style will help a ton with that one. Thank you. I'll briefly touch on the difference in complex creation and normal creation. The TLDR is that creations are essentially guided by their behavior mode, which you can predefine in the editor. It will not stray from the actions defined within and basically functions similar to the default Genshin enemy behaviors. This does not mean that they aren't great to use, however. Just plan ahead for the content that you're making and the interactions that you need. Just think of all the unique ways Hoyo uses their creations. It just depends on what you need for your stage, because not every stage needs custom enemy AI. It's a trade-off of more customizability versus complexity. If you want something infinitely more in-depth, then you need to use complex creations. When you're working with complex creations, you'll deal with a couple of unique node graphs, the creation status decision node graph and the creation status node graph. Honestly, if you just mentally replace the word status with state, it makes a lot more sense. It's probably just a bad translation. The decision graph's job is basically the brain. It decides what action the body needs to take by executing status graphs, depending on how you define the decision graph. So the decision graph is always running and always goes in sequence, trying to put the complex creation into any given state you've defined in it. The decision graphs node is just to figure out which state to run. And then the status graph is the actual logic that you're executing. The decision graph is always looping in sequence, so if it reaches a point in the sequence where a status graph is ran successfully, it automatically skips the rest of the pins. So for example, if we change our target's level to 10 here, you can see that means once it reaches pin 2 in the sequence, it just keeps triggering repeatedly as it loops through. Pin 3 will never be reached despite them both requiring level 10. This goes both ways though. Due to the sequence infinitely looping, if it actively is playing say pin 2 to 3 and pin 1 is valid and can execute a graph, pin 1 will automatically cancel the others and override them. So most important to creating a new enemy is having a plan and visualizing your enemy in and outside of battle. This is really helpful for the creation of complex skills. Here's a general design guide for this enemy in my head. We want him to toss a Spirit Ball-esque attack at enemies, and whenever the Mitachurl's health drops below half, they stop, go invulnerable, get buffed, heal a bit, and start the Saiyan transformation phase, or finish the Saiyan transformation phase. And we're doing our best to imitate the sounds and effects of the actual Super Saiyan power-up. So we want fast winds, buffeting around them, roaring, the infamous power-up sound. And if we think about doing these as skills that the Mitachurl can cast, then we need a way to not only power up once and only cast the Kamehameha after being powered up. So we can probably use one like boolean to track that. And knowing all this, we can go into the actual creation of these skills and the parts that power them. Our Mitachurl has 3 custom creation skills for each custom thing we want to do, as I was talking about. One for going Super Saiyan, one for Kamehameha, and one for Spirit Ball. And we allow Super Saiyan to interrupt other skills because he should stop everything he's doing the second he hits half health so he can start transforming. We also have a prefab made out of little star decorations to act as his wig. No snatching this one. Since he is a complex entity, let's check out his combat tab, where most of the customization for complex entities resides outside of graphs. From the bottom up, you can see the patrol template here. This correlates to a patrol path created over here in the main menu under path management. You can see it here. And the if we go back to the patrol template here, so we can set up any amount of patrol templates, defining exactly how our Mitachurl gets around the map in different situations. And you can trigger the different templates using their ID as our reference inside the status graph, which we will for our Mitachurl, and I'll show you that in a bit and go more in depth here. And here is the autonomous logic parameter template, and you can think of this as the brains of our complex creation. If we open it, I can explain a little bit better. You can think of the Mitachurl as a security guard, and the logic template is its rules of engagement. So you can be more or less lax depending on your gameplay, be it stealth, action, or whole arena battler, where nowhere would be safe. You can also choose if the creation calls for backup from nearby enemies here, or, for example, chase the shoplifter out of the store before it has to return to its original position, as well as define the territory that it guards. Think of approaching a chest in Genshin, how the enemies react and attack you if you get within a certain range, but if you run far enough away, they drop aggro and they return back to the area. You can have multiple of these templates and switch between them should you need. Do note the one ID here. We will use this in the status graph later. Here you can see our skills and our IDs in the Creation Skill Management tab. So, for example, Super Saiyan, Kamehameha, Spirit Ball, and their settings. And under the reference skills, you can see the skills that I showed you earlier in the Skill Creation tab. And this is how we let the Mitachurl know about the skills it has access to and their IDs, which we can reference in the status graphs to execute. And another important thing to know is that by default, a skill can only execute if all 3 cooldown timers are ready. So the global cooldown timer of the entire entity, which is up here, the specific skills timer for each skill, and the skill group's cooldown timer, as you can group skills together. So definitely tweak these settings as you desire and experiment. You can set the global cooldown timer in the top right under your global cooldown. Don't forget about that, as stated. And we want our transformation to supersede anything, so it has special options to ignore the global cooldown, etc. Here are our unit statuses. As stated earlier, we want to do a couple state changes on the Mitachurl. We want him to never die early so the player can't skip the phase. So we have the unkillable status here, which applies this, so his HP cannot drop below 0. And we have this one for when he is just started transforming, so he's invincible from any damage, so he can complete his cool transformation. And once he's done transforming and we remove that one, we give this state, which gives the buffs as you wish them to be. As you can see on the Mitachurl, we have the unit status applied by default, so he can never be killed until we're ready for him to. And whenever he is, we will manage it on the node graph side with a when attacked node, and we will decide whenever it's time for him to fully properly die. Here in the Mitachurl's custom variables, I won't fully explain all these yet because we're going to go into the systems later, but powered up is how we're going to keep track of whether or not he has started the transformation power up, and also phase transition, so that we know whenever he is all done. And then power up sounds, I'll go into this later. This is part of how we're going to be doing some cool complex sound handling so that we never hit the max sound limit. And active sounds is just how we're going to track the ID of each sound player that is running so we can clear it at a later point. And yeah, that's pretty much it. Now is the most important part to explain so you understand the concept of how our skills will work. We are doing a hybrid method of using both the animation editor and node graphs to handle our skill visuals and sounds. This allows a much more precise control over timing and customization. So first let's go over to the animation editor under creation custom skills, and let's check out the Spirit Ball one. The top buttons are where we pick our pre-existing animations that the creation will use in series here. And below is the timeline where we can lay down both our visual effects, as you see in the VFX playing ones here, and any no graphs you want to trigger at certain points in the animation for timing purposes. See, as you scroll through, you see the animation triggering, and that's when it spawns in the graph the ball to throw. Since we'll be doing a hybrid approach, we are handling just the starting VFX here and then transitioning over to our node graph. To explain this a bit better, basically we are using this two-part approach because like in DBZ, we want this wind up here where we'll have various charging bits happening. And we are going to be using a custom prefab projectile so that we can control the VFX and sounds a lot more since we can't stack more on the actual monster. So here we're just having the VFX make it look like he's throwing the attack. But here is where we're going to use the node graph. And the node graph's basically going to spawn in a prefab that has these VFX running. So it just looks like a smooth continuation of the throw. But this is where the prefab will actually spawn, and then the motion device will activate and shoot towards the player. So at no point here is there any actual attack, but it'll look like there is. And then we transition to the real thing when he throws. And that's way we can time exactly when the projectile leaves his hand with the motion device. Unfortunately, as you'll be able to tell here, the effects aren't actually following the hand as it should. And that's because we have a different unit attachment point for these. And sadly, the animation editor only respects the default attachment point for following. So you actually have to load the game to see how these look in the end, which is very cumbersome. Or you can mess around with the component VFX editor, and I believe that actually does show the tracking. Let's head over to the Super Saiyan transformation animation editor. This one's only going to be no graphs, but I'm here to show you the animation. So basically, I want to explain the concept of how I figure out what the skills will look and sound like. So first, we go through the animation list and find an animation that will hopefully fit what we want to do with the enemy. And I feel like this one fits the power up really well. So it has like this little bit here where he wobbles around and I can imagine like the wind's buffeting around him and him slowly gathering power as he's roaring. And then here he has this meaty slam into the ground. And I feel like this is a great like rock crunch sound right here where he hits the ground. And then he kind of struggles a bit as he's like in the last bit of the power up phase. And then he explodes the hand out of the ground, fully crunching the earth. That's what I'm picturing in my head for the transformation. And at this point, he's gone full Super Saiyan. Super Saiyan. He's gonna be glowing. He's gonna have his hair. The sound will happen around here, like right around this point. The little zing sound. And as you can see, he will be fully stanced up and ready to attack here. And so, I feel like you kind of see what I'm going for here. Bam, and then charging up a bit, and then bam, zing, and then pulls back, and he's Super Saiyan transformed. You have to be kind of creative with what you do because you can't do the custom animations, and you are gonna have to try to the sounds and effects and stuff. But I feel like this is a great starting point. Another useful thing is I watch a lot of anime scenes for the transformations on YouTube and listen to a lot of soundboards actually of the attacks and stuff, the various stages of it. I listen for like the key sounds, like the just various like really notable sound effects throughout any era of the show. So it's like clearly the key signature of those attacks or the transformations, etc. And I try to find equivalents of those or find sounds that were close enough that I could kind of stack together to create those sounds, or ones that I could use the pitch shift. Actually, I'll show you in the SFX editor. So for example, with the SFX and the general concept, I now know I have a shopping list. I have to find some visual effects like wind rings that look like buffeting wind spiraling out from him. So I can place on the ground some cool glowing animations to give that iconic glow. The prefab I showed earlier with the hair. And a lot of searching for effects and sounds is trial and effort. You have to play around, get ones that look good to you, play around with their scale, twist them around, see how they fit. It'll become a lot easier next version, thankfully. as the next update has previews for VFX in the UI, which is amazing, which I've seen in a lot of videos. And so an example is we can't have the Super Saiyan scream, so you had to get creative. So we had to use roars for the monster, which hopefully kind of gives the same vibe. And for the other sounds, like for the winds, we had to find like looping wind noises, and for the wind buffeting effect, and for the energy and power radiating out from the body, causing those dust clouds and stuff. And that's easy enough to do with like Animo sounds. So you find like Animo labeled things, and for like the rock crunch, obviously you'd think like Geo sounds, and just things like that. It's a lot of trial and error, but it's honestly really rewarding and fun. It is a little hard sometimes, but whenever you find the right sound, it just clicks. Or as you can see here, you can play around with the playback speed to like kind of change the pitch a little bit to get these sounds that aren't actually in Genshin. So for example, the transformation sound, which I'm really proud of, the actual like zing sound, that's a monster cry, but pitched a lot and sped up, and I think played twice to make it even louder. And just things like that, you have to be creative, kind of like a Foley artist. Have you ever seen the behind the scenes videos of those? So you just got to get creative with it and try to match it up. If you're doing your own completely custom skill, this is obviously way easier because we're trying to match an existing sound asset, which we don't have access to. So yeah, it's just a lot of creativity, but honestly, it's really fun. One more important thing to note is that there is a 10 SFX player limit, so you can only play 10 sounds at once on any entity, and this is why we will create a sound handler later to repeatedly clear the playing sounds. But this is just something important to keep note. And also, you can also play the VFX combos at the same time. On the VFX playing list, as you can see here, you can get preview combination, and you select the different effects you created, and you see our Kamehameha here. And also, when you go into the sounds, I keep a notepad of sounds with little notes for what they were and tested on an empty object using the player here. And I just took note of any sounds I found interesting, and then eventually created like a list of the sounds that would be played. So like the wind sound, then the power up, then the rock sound, then the zing sound and stuff. And then that's how I figured out the order of the way the sounds would play in the sound handler later. I want to quickly go over some node graphs that are important. These are two composite or there's actually 3 composite nodes that are used in this project. First is this. I got this idea from Steld in the creator community. Basically, we create a composite node that is a timer, and you see we take the input pin as the start of the timer here, and we get the timer name for the composite node and the delay of the timer, and then obviously the timer trigger happens, and whenever this eventually goes off. And this checks for the same field here because you can combine these 2 pins into one so that whatever's typed here is used here and here. And this basically creates a composite node we can drop anywhere to create a delay anywhere in the code. This is really handy even outside of complex creation. So I really suggest starting to do this. This has changed my life, and I'm not even being dramatic. So I really highly suggest this. It's really handy. I'll click on each one of these pins in case you need more information on it, although it is pretty straightforward. So to explain how we're handling the automated sound bits, first we need to go to this tab, which is the Advanced Data Management tab over here in the main menu. And here we're creating our own custom lists, basically. So as you can see, we have the sound ID to be played, the playback speed, and whether or not it's looped. And then eventually we make a list of these. And as you can see, the list here, and these will all be available in the project file and in the description. And these just basically contain the information for each one of the sounds to be played. And this would be looped over in our sound handler, these lists, to add these to SFX players. That way we don't have to have a sound player node for every single sound all throughout the code. This just saves us a lot of nodes and also a lot of busyness in the UI. And it's also just really handy to quickly reference these sounds from a different UI here. And then in the actual nodes here, you can see it's just basically we feed the list in that we were talking about earlier into this composite node, and it iterates over that list. And for every item in that list, it adds a sound effect. And you can see here it splits the structure off to get those individual little bits that I was showing you earlier, and just adds them into sound effects. And if you see this looped version here, if a sound is looped, then we take this active sounds variable and we insert the ID of that player into that list. And then later I'll show you the next composite node, which is the final one, and it basically will iterate over this and delete any sound player that has active looping sounds on it. That way we can keep the sound players clean and cleaned up. And as you can see here, it's really simple. It gets the active sounds list that we created in Sound Handler, iterates over them, clears each sound effect player, and then once it's done, it clears the list so it can be filled again. Now we can go back to the variables, and I will explain this really quick. You see the power up sound list here. This is just that list in the data management I showed you earlier with the different sounds that'll be played at different points. And so we just store this on him to be used later. And again, in the events data management tab, you can see basically it's the wind sounds, it's the powered up sounds, so the sounds that are going to loop permanently while he's walking around, and the Kamehameha sound, because it's a lot more layered and complex than the Spirit Ball sound. So we're about ready for the final part. I'm going to go over the actual node graphs that do these skills. I want to quickly remind you how the skills are going to work. For the Super Saiyan power-up, we'll have 3 parts: the wind buffeting, VFX and SFX, the rock crunch, and then the actual looping final power-up effects and sounds, and the hair being applied. And then for the Spirit Ball, he's just going to do the charge up and then launch it. And then for the Kamehameha, he's going to do a similar charge up and then launch it after he does his spinning around animation at the apex of his spin. So that's going to be 2 parts to Kamehameha, 1 part for Spirit Ball, 3 parts for the power-up transformation, which means we will have 6 signals total on the client side, which I will show you in a second. So first, let me introduce you to the node graph variable. This is the only one that matters. It's called counter, and it's 0.5 floating point number. I will explain what this is in a minute. And now, most importantly, the signals. Ignore signal 1. So this is for the wind pulse. This is for the rock crunch. This is for the final glow. This is for the first phase of the Kamehameha. The second phase of the Kamehameha, and you see it has a location vector. That'll be the location of the player to launch it at. So it's going to send that to the server side via the signal. And the Spirit Ball, same thing. And then you can find all those here in the client editor under the creation skills. And so you see if you open these, it's just going to be sending signals, except 2 of these, which is launching Kamehameha, which will send the right-hand attachment point information. Yeah, sorry, it's not the enemy entity location. It's the arm attachment, because it's telling you where the ball will be attached to. And it's sending that to the server. And that's how you know where to spawn the prefab to launch it. And then the same for the Spirit Ball, but on the other hand, because the animation is changed on that one. And now that you understand how those signals work, you can understand better the Super Saiyan bit. So you can see here, this is starting the 1 signal to do the wind sounds. This is sending the other signal, and this will start the rock sounds. And this is sending the final signal, which will apply the hair and do all the various permanent looping glows that will attach to them. And for Kamehameha, see, we have these. They're not going to track properly, but these blue trails are going to follow his hand as he goes through, and they last longer than you think. And this is where he starts charging up, so it starts getting a blue orb, and he's going to kind of rear back, kind of like they charge in the show. He's going to spin around, and at this point, the code to launch, he's going to be facing the player at this point. He won't here, but he does in the actual game. And this one, he's going to launch the orb at the player, and this will be the real prefab. It'll fly towards the player and attack them. And that's using those signals I showed you. And here, the Spirit Ball, this one's a lot simpler. It just plays the VFX and throw. That's when the real prefab and the motion device comes in. and I'll show you the nodes for that now. As you can see, the decision graph nodes chooses sequentially what skills to run based on what is happening in game at any given time, as explained earlier. The first one is the Super Saiyan transformation, which only happens whenever we have a yes from XORing powered up and phase transition variables, which we set in the actual skill node graphs. And if that passes, then we transform, and we do this so we only ever transform once. And then this right here is Kamehameha, and as you can see, we only ever... just an update, because I don't know how this happened, but somehow I actually lost the setup here for the patrol in the previous video. But this actually uses a logical OR, and it checks whether we're in battle and also whether we're using a skill. And if either of those are the case, or logically OR, it will not execute. That way we don't accidentally interrupt skills or whenever we're in combat, etc. So just quick update for that. We have one more important custom graph to show. Since we are creating our own custom local projectile, essentially, we have to have a way to tell it when to destroy itself. So here we're just doing the basic checking if the entity we collided with is actually alive and on the field. And the reason for this, I believe, is so that it doesn't collide with walls. I'm pretty sure this only reports for actual entities, like proper entities. And if I remember correctly why I said it like that. And for this, we're just checking, obviously, the factions, if it's an enemy faction. And then we wait a little bit for the attack, because it just gives it more impact. And then we destroy the attack. And finally, before we get on to creating these skill parts, this is the graph that tracks whenever the Mitachurl takes damage. And for example, if it is below half the Mitachurl's HP and we aren't powered up yet, so as you can see here, if we aren't powered up, then we go down this branch and we add the invincible status, and then we set the phase transition to yes. And then this is also used when we're attacked. If you get on this branch, you see the condition. It checks the current HP, and if the current HP is below or less than or equal to 2, then we know the creation is ready to die. And at that point, we list through the entities that it owns to find the hair, because we need to destroy the hair. That's another reason why we have this custom death here, so we can delete the hair whenever the entity dies, because it's hard to track entity death like that and handle any entities they own beforehand. And then we remove the invulnerability status and kill the enemy ourselves. And with those specific node graphs done, it's a good time to show you the prefabs for the actual attacks. So here is the Kamehameha one. So you see it's just an empty model, which is a great thing, a great starter for creating a really complex component prefab. And you can see it has an ability unit here, just like a local projectile would. It's a hitbox attack, attacks the hostile faction. You can edit all the attack damage data here. And you can see for the Kamehameha, it has these cryo explosions and a bigger one for the actual on hit. And then in the components, you see the actual VFX here. And also we have some of the sounds here. Since it is a different entity, we can just manually add those. And we also have a motion device, which we will handle in the node graph, and the on-hit detection area, which has our on-hit trigger for the ability unit. You can see and understand these more by watching my gun tutorial. And also, you can see the node graph here for the server-side filter. So this just tells it when to destroy itself. And the spirit ball is pretty much the same. It has the spirit ball ability unit, and it has that hit. Actually, I'm not sure how I feel about yeah, I think it's because of the rock. And then has this for the actual hit. And it has the effects as well as the on-hit detection trigger with the ability unit. And the motion device component, so we can trigger the motion device, which we will in node graphs, the SFX player, and the node graph for the server side filter to destroy itself whenever it hits something. And these are the prefabs that we'll swap in on the ability cast. Now for the final 3 node graphs, and we're done with the graphs. Let's start with the simplest one, the spirit ball creation. You can see the signal here from the animation editor and the location of the hand. And we feed that the entity location into this to get the closest target that we want to target, to get the player location. So we get the closest player, and we turn that into a velocity vector using some math here. And then we feed that into a motion device here. And here you can see where we create the actual prefab in the hand. And then it gets its motion device at that point when it's in the hand, and then it gets launched. For Kamehameha, we have 2 stages. We have the first signal here and the second signal. And the Kame signal stage starts the sound effects. As you can see here, it gets the custom power-up sounds off the Mitachurl. It gets the Kamehameha sounds list, feeds into the sound handler to start playing. And then we mount the temporary VFX as it spins around. And then we go down to the second signal, which plays eventually in the animation. And it's similar to the spirit ball pretty much. We get the closest enemy. We spawn the prefab on the correct hand location. And we add one more sound for the launch. And here you can see we are clearing the placeholder VFX for the actual prefab after the prefab is attached to the hand, so there's no weird transition. And then we activate the motion device via this location here and the math to track it towards the target. So now onto the finale. I'm going to quickly show the signal. So you see this is the wind pulse. This is the data that handles the wind buffeting. It looks complex, but it makes a lot of sense. I'll explain in a second. This is just the rock crunch sounds. And this is the final Super Saiyan glow. I'll explain these all one by one. So if you watch the clip and you see how the wind VFX grows in size as it reaches the outward edge, well, this is a cool effect I want to show you, and this is part of the entire reason we're using the node graphs to set up these effects in tandem with the animation editor. These are some procedural animations, basically, that we can change with the numbers to any amount or speed we want. So if you observe this code block, we set up the powered up variable here, which is important, as you remember, for Kamehameha and the powering up. And we have a timer here running at 0.3 seconds. 0.03 seconds. And this starts a loop here. This less than equals here sets the amount of times that it will loop, basically. And this equals here makes it so that, as you can see, it's connected to this double branch in the top right up here. And that just connects to the sound handler, which takes the list of sounds, the wind sound, and adds it to everything. And this transformation is by far and above the most complex sound-wise, which is why we have the sound handler, by the way. It goes through a lot of different sounds, and it used to be like 10 times the amount of nodes here. So basically the loop continues and clears any previous wind rings before mounting new ones. And the zoom multiplier down here, as you can see, is hooked into the node graph counter variable we created earlier. It's incremented here in this loop. So every time this loop plays, the wind current goes up around half a size every single loop until it reaches the max zoom multiplier, or max distance of 4.5. And then it resets the counter, therefore meaning the rings start in the center and go out towards the edge. And once they reach that 4.5 size, they reset back to 0.5. And they just keep looping like that, which gives that ring buffeting effect. And we also spawn some more rings just to give this kind of persistence effect. And if you stack 2 rings in one location, it gets rid of some of the transparency, so it makes it look like even thicker winds. And so we use that to get this like really cool, persistent, outward flowing effect. And I think it works really well. And I'm actually really proud of this whole system here. It may look complex, but once you like read and understand it, you understand that basically all it's doing is increasing this multiplier repeatedly and clearing, repeating, clearing. And then once it's reached the point here, which is just kind of arbitrary, that match the timing of the animation, it clears the effects and moves on. Not much simpler. This is the rock crunch sound signal. It plays the slight rock crunch as it hits his hand in the ground, and then when he crunches after a delay here, so it lines up with the animation well, it plays the louder one, which is kind of covered up by the transformation sound, but it's okay. I still think it adds something to it. And the final signal is the SSJ glow. This one creates the hair prefab and attaches it to the Mitachurl, spawning as close as possible to reduce load problems. Then playing the glow effects. And since by this point he's fully transformed, we remove the invincible status and add the buff and recover the HP. And we clear the active sounds that are left over so that we can add the permanent ore sounds. And that is pretty much it. Thank you so much for watching and supporting the channel. I'm still extremely new to YouTube, so if you have any tips or if I got something wrong, please let me know so I can pin a comment explaining. I will be uploading the new sound handler as a separate asset and also uploading the entire project file with tons of notes. Please do check it out. If anything here confused you and if you have any questions or need help, please let me know in the comments. And definitely make sure to read the project with all the notes. And please check out the official Miliastra Creator Front Discord and come hang out with us. Everyone there is extremely nice.